Hello! In this video I will show you how you can make a Battleships game in Blazor. Now Battleships is definitely not my favorite game, and hopefully I got the rules right, because I don't really know the rules, so I had to look it up. But nonetheless, it is a very interesting project, and you will see how easy, well, relatively easy of course, it is to do something visually dynamic in Blazor. How easy it is to sort of make the objects change, appear and disappear and all that stuff, and how little code it requires. Now we won't be comparing anything in this case, but you will see just that idea of how little of it we actually need to execute this. Now then, let's take a look at how it works, and then we'll take a look at the actual code. So this is the board. This is the setup. We have three stages basically. We have the setup, then we have the gameplay stage, right? And then you'll see who won or lost, and that's it. We have three stages. Now in the setup, you select which basically ship you want to add in your board, in your map. And you add this one, then that one, then this one, and this one, like that, and this one. But you see there's a bit of a safeguard. See, I can't do it here because there's already one here, so it wouldn't fit. If I do it here, it fits perfectly, okay? Now then, we are in the game, and this is the player map, okay? This is my map, and this is the UI map, right? So we can try and hit. Okay, now I hit this. At the moment there's no randomizer, and there are a few things that I sort of left out. I will be giving you suggestions as to what perhaps tasks you can do if you want to practice Blazor on top of this project. So if you want to get sort of more real-world practice in a way, because in real world you don't usually start your project from scratch, you work on an already existing project, right? So this is how it works. If I hit an empty one, it's white. If it's a ship, right, it gets destroyed, it's red, right? Very simple. And once every ship is destroyed, that player loses. Now also notice, once I hit my turn, like that, it also hits for the UI, right? Okay, now it should have been maybe AI or COM. I don't really play these games, so I don't know what they called, but that's not really the point here, right? So let's jump into the code and see what's happening here. Now then, we can begin with the setup, okay? We can begin with setup. I will show you the sort of basic layout first, and then we can get into the data generator, okay? So the project, right? The project, what we have is a simple Blazor client-side project, okay? Blazor WebAssembly as it is called, right? And then we have our index.razor, nothing too fancy here. Then three components: the map player, map setup, and map UI. Now you might be arguing with me and saying that I could have done one component reusable, and that is sort of possibly true, but it would have been extremely complicated, and it would have been quite unreadable as well, in my opinion. And most of these are quite different. You do have the same idea for generating the map, okay, same idea, but everything else is quite different. Player and UI, or AI as it probably should have been, right? My mistake. These are very, very similar, but the setup is completely different almost. Now with that, we also have data generator, and we have grid models. If I go into grid models, it will be just one simple model, and that is a square, okay? So the whole structure of the game, the whole structure of this program is based on this class. It's based on this square, right? It gets generated, regenerated, changed, modified, right? It does have an ID, okay? First, it does have an ID that we generated as GUID, you'll see that later. And then we have 3 Boolean values. The first one, is it a ship? Second one, is it a destroy ship? That means it's red, right? And is it empty? If it's empty, it's white, okay? Then the computer already knows that it's been sort of tackled, right? And it was not a successful attempt. Everything else is quite obvious. If it's destroyed, it's red, right? By default, all of these are false, okay? And therefore the square is blue, as you saw in the example. Now you can actually download this code from Patreon, as well as any code example that I have on YouTube. You can download the source codes from Patreon. Okay, so other than that, we also have these coordinates, okay? And coordinates, in this case, they actually match the coordinates that we have in the HTML. Okay, X and Y, they match in HTML. We go by 25 increments, okay? 25, then 50, then 75, and so on. And then we can multiply it, okay? You'll see that later how it works out, but it does work out quite well. But basically, you just have to know that X and Y will be in 25 increments. So this is the model, this is the main model, and this is basically the backbone of the whole application. This is what the whole application is based on this little data model. Now it may seem a bit strange at first, why don't we have ships and whatnot, different pieces, but it's a lot cleaner this way. It's a lot more efficient, and you'll see that soon. Okay, so we have also a data generator, but back to the map for a bit. And for the map itself, we use SVG. We don't use canvas because we can't do loops like that inside a canvas, and we need it. It's pretty much the same thing in general. Now, if you're very much into HTML, you're probably going to start arguing with me, but it doesn't really matter, right? I try to keep the things simple, and I try to make things work. If they work, I'm going to be perfectly happy with it. So we have the size a bit bigger than what we maybe need, because we have borders, okay? We have borders, right? And borders do add up to that a bit. And it is a perfect square, okay? It is a perfect square full of squares. That's how it works. Okay, and then we have, for the setup, we have these buttons. So you see we have ship type. Which ship type is currently being added? Okay, you click on Foursquare ship. That one is currently being added. That is type 2. So if it's not added, it will be set to false. Okay, if it's not added, it will be set to false. And you see we go through these if statements. Like that. We have ship 1 is not completed and ship type matches. Then we generate the ship onto the canvas that we have, right? Onto the border, onto the map. And we use method add ship. Okay, add ship. If it works out, then ship 1 completed, true. Once all of them are done, okay, once all of them are done, we check for that every time, and then we invoke on complete. On complete, right here we have on complete. That is then accessed in the index.razor, and that changes one simple value, and then the game begins. Okay, that's what the setup does. Now then, onto the data generator. So these are just some static classes. Again, I wanted to make things as simple and as readable as possible, with as little code as it is possible. So let's take a look. We have generate squares. So this is the first thing that we have. Generate squares. This basically generates the map. Okay, the map. The whole map this thing generates. It returns a list of squares, right? We have a square model, you saw that previously, and it generates that. Now then, we set the result, and we have this sort of rather complex algorithm. Okay, it may not seem like a lot, but you really have to put some thinking into it, and you have to be quite careful with these things. And you can make it bulkier, you can make it maybe more efficient, maybe less efficient, right? It depends on what you do and how much time you spend on it. But the idea here, we need 100 squares, so we loop 100 times. Okay, we loop 100 times. Now then, every 10 squares will be a new line. Okay, it will be a new line, or rather in this case it will be a new column. Okay, it will be a new column every 10 squares. Now we could make it the other way around, but in this case that's what it is, right? So we generate one column, right? On every one it goes current y plus 25. Remember, I told you it's 25 increments. Okay, 25, 50, 75, 100, 125. Increments of 25. So it goes and goes and goes and goes. And once it reaches 10, 20, 30, meaning that it's the end of that particular column, it moves on to another column. And the way it does is quite simple. It resets the y, so it starts again from the top, right? It starts once again from the top, but it moves to the right by adding to the current x, 25. Remember, again, 25 increments. Now, this was just used for testing. You can ignore it. Actually, I'll delete it. We don't need that at all. Okay, and then we have result, add. We add to the list. And what do we add? We add square. We add square, and in that we have ID. ID, as I mentioned previously, we generate as a GUID. So we use new GUID, which then you need to convert to string. And as for the coordinates, we set x as the current x and y as the current y. A very simple procedure. Obviously, to make it like this, you would spend a bit of time thinking and planning and strategizing, but at the end it is not too much code, and it is quite readable. So this is how we generate it. This is how we generate the sort of main grid, the main map. Now let's take a look at how you generate the other things. Now then, to generate ships, we have two methods that we will need. The first one is actually add ship. Okay, that's the main one, the first one. This basically converts a specific square in the list into a ship square, right? And the ship square would be simply setting the Boolean value is ship to true. That's all that a ship is. And then later it might be destroyed, right? So is destroyed will be true at that point. But we start obviously with simple ship, ready to be destroyed. And this is the method. Now it is relatively complex. Okay, it is relatively complex, this whole arrangement. But I'll try to minimize it a bit. Okay, and we start with a sort of simple check. Okay, simple check. We start with is vertical, right? So a ship will go either to the right, from left to right, right? Or it will go from top to bottom. That's the two ways it can be generated in this arrangement. Now, you saw in the setup it was only doing horizontal, and that is one of the tasks I would suggest for you if you want to practice. Simply add the capability of, or for the user rather, to choose if they want to add the ship as vertical or as horizontal. By default is horizontal, but it could be vertical, right? So that goes at the end, right? and it has a default value. So default value is false, therefore by default the ships are horizontal, right? By default they are horizontal. The next thing we need to provide is a list, okay? A list of squares, or in other words, the map, right? We provide the map. Now you may be thinking, we are not returning anything, so what's happening here? How will it work? Well, it's quite simple really. When you create a list, the main list, right? The main reference point for that list is the declaration of that variable. Other than that, you can pass it through methods and it will only be used as a reference. It will only be used as a reference. So therefore, if I change something into, or rather inside this list in this method, it will affect the original list. It will not affect it as this particular variable. It will affect the original list from which it came. Right, so it's a reference to that original. That's how lists work, and that's how you can have issues. Okay, you might just pass it like that, you want to return, and then you see your original has changed. If you don't want it to change, if you don't want to have a reference, you would need to declare a new list somewhere inside this method, right? And then set it to that provided list, and then you work with that newly established list. That's how lists work, and you do always have to be careful about it. You do always have to think about it. Otherwise you will be in quite some trouble, and it probably will be difficult to troubleshoot. Now then, the next thing we need to have is the first square. So this is the first square of the ship, and the later ones will go to either to right or to the bottom, right? You have 1, 2, 3, 4, 5. 5 is the largest one that we have. You could change these numbers up, but you will need to change a few things as well if you want to do that. Now, a square count is basically the size of the ship, okay? So let's start with, let's start with vertical. Why not? It's pretty much identical. Okay, it's pretty much identical. And first, what we need to check is if the ship fits at all. Okay, if the ship will fit into the map. Now remember, everything is at 25 increment. 25 increment. So we check if the counts will actually fit, if they will fit inside. Okay, if they will fit inside that map. We check for that, and we check the y value because it goes to the bottom. We don't need to check for the x value because it will stay as the same all the time, right? It doesn't matter if it's 1 or 5. Now then, the next step is to set first square to y. Okay, or rather next square to y, okay, of the first square, because we begin with generating the first square. Okay, now before we do something, before we actually insert it, we still need to verify. And that is because a ship might already be created. Now I did showcase that feature, that safeguard, when I showed you how to do or rather how to play the game. Okay, so we need to verify. Now the way it works, it's quite simple. We have square count. Okay, we have square count, and that will basically loop and check through all those squares if any of those squares is not occupied, right? And for that we do find. Okay, we use a bit of link, we use find, and then we do x equals to square, first square x, right? And then next y. The reason it comes from first square directly is because if it is vertical, the x value will never change. If it is horizontal, you will see that in the bottom it will be different, right? It will be vice versa basically. And then the y has to change on each loop, on each cycle. So that, for that we use next y, which we set right here. Okay, and then we retrieve is ship. The property is ship. If it is true, okay, if any of those are true, we return false because you simply cannot create it. Okay, you cannot create it anymore. So we have to return false and we quit the whole process, and that's it. Now, we do increments of 25, we go through them, and if this succeeds, we can go into the inserting phase, right? So for the inserting, we will go through the same procedure. We will reset the next y. We reset the next y. Okay, like that. And then we go again. The same kind of a loop, except for, instead of checking if is ship, right? Checking for that boolean, instead of that, we set is ship to true. See, is ship, we set to true. We find and we set, and that's all we need to do, because again, the list is the reference of the original, so we don't have to recreate it and assign it and return it. We just deal with that reference of it, and that's it. Quite straightforward and quite simple, but then again, quite tricky and can be quite troublesome sometimes, so do be careful about these things. And once again, on every cycle we increment that to 25, and it goes for as long as we have basically squares that are not yet set for that particular ship. So that's what we have, at least for the vertical part. Now, for the horizontal, it's pretty much the same thing. It's pretty much the same thing. We have next x, okay? So instead of next y, we have next x, and then everything is pretty much reversed, okay? X equals next x instead of y equals next x, and we do the check, okay? We do the loop for the checks, and then we insert it, and that's it. Quite straightforward, but it is a bit tricky to do and to understand, and again, you do have to be careful about these lists. Now, once again, you can find the source code on Patreon, you can play around with it, and I already gave you some suggestions on how you can maybe improve your Blazor skills, practice a bit and all that. And if you want to learn Blazor, you can actually watch my Blazor course. It will get you from start to finish in terms of learning Blazor. Also, you can take a look at my Stripe course on how to integrate payments in Blazor and .NET Core API, .NET 5 API with Stripe. Okay, so the generate ships, okay, generate ships. That's another thing that you can play around with, you can practice on. This is for the AI part, okay, so this is for the computer map. This is not for the player. The player can establish or set up the map themselves, but the computer needs it generated. Now, at the moment, it's not randomized completely, but we do have R&D, random set up. Okay, we have random set up right here, and so you can change these. Okay, you can change these into random, so say from 2 to 4. But do be careful, test them out first, and then only then you put a random interval. You cannot do it right away because they won't match and they won't get generated, and you will have a mess on your hands. So the way it works, it's quite simple. I do have these console write lines because it may be easier to test it like that. You can see on the developer tools right away without having a need to debug it. Although if you need to debug Blazor, you need to use either Chrome or I believe Edge will work as well, Microsoft Edge. Those two browsers will work, the other ones will not work. So do remember that if you're going to debug it. Okay, other than that, we do add ship, okay, and we do all the types. We have 5 square ship, then we have 4 square ship, then 2 ships of 3 squares, right? And then 1 ship 2 squared. Okay, and that's it. Now, the way we add it, we just do 25 ring increments, as you remember, and we use those coordinates. We kind of push them around a bit. So this one will be starting at 50x and 25y. This one will be starting at 75y. But again, if you replace the multiplier with a random interval, you can actually randomize this. So do try this, do practice a bit if you need that. And then we provide the square list. Now the square list actually comes from the top, from the parameters here, the square list. So it's a reference of a reference at that point, but it works perfectly fine. Okay, and then for the vertical ones, we have true. Okay, we have true for the vertical ones. And then we have a little exception. If you're going to be doing that, you might need this for testing, just to get that exception out, or maybe put a breakpoint in here as well. If everything is successful, in theory, it should return true. At least that's what should happen, right? Okay, so now we know how we generate everything, and we can sort of get into the actual user interface, how it gets generated, and how the clicks are handled. At this point, we can take a look at the index.razor. Index.razor, that is the sort of base of operations for this whole arrangement. Now, we have a few variables in it. The first one is setup. Is setup, I should say. And it is set to true, because once the game begins, it is set to true. Now, we don't have any kind of a reloading capability here. You simply reload the site and you have a new game, right? But is setup is very important, because it wraps basically everything. Not exactly everything, it is still wrapped by status, which I will explain. But if the setup is set to true, then we have map setup. You've seen map setup before. What it takes is player's list of square, right, for the player. And then it has onComplete event. And on that event, we simply set is setup to false. So meaning that the setup has finished. And once the setup has finished, we can provide the 2 maps for the computer and for the player. We provide the 2 maps after the setup is finished. That's all there is to it. But again, remember, the list, all the lists, they work on reference kind of a way, right? So we provide that, and then the same thing goes into squares and can go back and forth as it is just a reference to the original, which is right here. Okay, we have squares player, and then we have squares AI. Okay, in this case I named it probably correctly, not UI but AI properly, right? It could be computer, I guess com they call it sometimes, but the point is that one is for computer and the other one is for player. Now with that we have lives left. Okay, this is a very important part of it, otherwise the game will never end. Okay, so once one of the ships for the AI or for the player gets destroyed, it goes back to the index.razor and it basically subtracts 1 from this number. Once it reaches 0, one of the players, well, either player or the computer, has lost, and we notify that by changing the status. Okay, so the first status is game in session. I left a few comments, and again, you can download this code from my Patreon. Also, you'll get some great deals on my courses, some free courses you'll get if you support me on Patreon. Now, the second one is player 1, and 3 would be UI 1. Okay, that's what we have. 3 statuses. And as you can see, we have basically status 1 wraps everything right here. It wraps everything. And then we have else if. If it's status 2, then we show that player won. If it's else, then UI won. Now, I can't pronounce that word properly for some reason, but you get the idea. So let's go down a bit, and then we have a very important, another very important, everything is crucial here. We aren't wasting space and time with useless variables, right? We have, is AI turn false? The reason it is false is because it's easier probably to get started this way. We don't have to initiate the first turn for the AI. The player starts and then the AI follows. And I'll explain how that happens. Now, we also have, as you can see, map player. So this is a reference for the player's map. And that is so that the AI can make a turn on its own, right? The computer can play on its own. I'll explain it later. But another important, of course, thing is the onInitializeToSync. This is where we basically initiate the game, which means generating squares for both AI and the player, the computer and the player, right? And then we generate ships for the AI. Now, remember, everything in terms of the lists, they work on reference. So we simply provide that, and the original right here will be filled with ships. And do remember, there is an opportunity, I guess I would say, to actually practice and improve on this application, to add a proper randomizer. Everything is in place, ready to do it. You just need to put in a bit of time, a bit of thinking, and create a little randomizer. Otherwise, it's a boring game, right? So we have generate ships, and that's where we end. Everything is ready to go. And once the player is set up, we can start playing. Now, after that, we have change turn from UI, okay, and then change turn from player. This is a bit complicated. And in order to understand this, we now have to take a look at each map setup. Let's begin with the UI, well, actually AI, right, map. And the map is very similar to what we had in the setup, but we do have a bit more in it, right, a bit more. It's in SVG again. We have rectangulars as our shapes. And then we have a for each loop, which loops through squares. Squares taken as the parameter. You saw that in the index.razor. Now, you see something commented, and it is for a good reason. When you are testing this game, right, when you are testing on the browser, you're clicking, you want to see if it actually works, if it finishes, if the black changes to red when a ship is destroyed, you need to actually see the opponent's ships. Otherwise, you'll be playing the game and it will be just overly time consuming. It will be a waste of time, in other words, right? So you want to see the ships, and therefore you could uncomment this part, and then you would be able to see the ships in black for the opponent, and you would be able to win the game quite easily. Now, the next thing is destroyed, okay? So we check for it to be destroyed. If it is destroyed, we do everything that we would do normally, except for we will have a different color, right? That's the red color. The same goes for is empty. It will be white color right here. Again, nothing too fancy here, nothing insane, right? And then else, for everything else, it will be blue dots, the water, I guess we represent, and we will have a click event, right? We have a click event. Actually, we don't need this click event. We don't need it. I just left it there. But everything is sort of handled on its own. And as I mentioned previously, we do not need this one. It shouldn't be here. Now, we do, however, need this. We do need the method, right? We do need the method. Now, you might be thinking, if we don't need this click event and we need the method, how do we interact with it? Because in here, there's nothing else. So which part will execute the event, right? Well, the answer is it will be executed through the index.razor. And let me show you how. If we go to index.razor and we go below, right here, UI select, right? So we have here the whole selector. Now I'll get back to explaining that previous thing, but this method executes that other method. But then again, how do you access the component? Now, to access the component, we need to go to the top, and you see we have this reference for map player component. And if I go to the top a bit more, you see we have map player and we have ref. So this allows us to reference that and basically access those methods from there. There are some tricky bits, and you can watch my Blazor course to learn more about it and more about the Blazor in general, because there are some tricky parts to it that you have to really understand in order to make use of them properly. But basically this allows us to execute that method that is inside the component. Okay, so getting back to the component quickly, we can go down to the bottom here. Okay, and it takes a square. For the player, it will be a similar arrangement, but it will come from click, like you see right here. Okay, it will come from click, and then we have, if it is a ship, okay, if it is a ship, then we set is destroyed to true. Okay, is destroyed to true. And then we invoke and turn. Okay, we invoke and turn. And if it's not a ship, we set it to empty because it's already been checked, right? And it's not a ship, it wasn't destroyed, so we just have to set it to empty so that we know that it's empty, right? And then once again, we end turn with false, and we can end turn with true. Now, if you end turn with true, that means that the ship was destroyed. And at this point, we once again have to get back to index.razor, and I'll show you what happens. Okay, so let's see. Now we have, rather this one, right? You see, it's a bit tricky. Maybe I should show you like this, right? We have a map UI, okay, and that is change turn from UI, right? So from UI, we change turn to a different arrangement. Now, I was showing you in a bit of a wrong way, I guess, but the idea is still the same. It changes the turn, right, from UI, and it takes an argument. So once we go down to the bottom, basically what happens is it takes the result. It changes the turn depending what the previous turn was, whether it's a player or the UI. And then we check if the result is true. If it is true, we subtract 1 from lives left. Again, depending on, actually on the opposite of the turn that was taken, right? So if it is AI turn, we subtract from that, and vice versa, right? So we do all that, and then if it goes to 0, we do status 2. That's it. Okay, and very similar thing from player. Now, I should have removed the async part, that's why it's green. Doesn't really matter. It works fine, but that's just the way it is. So we have this AI turn, right? Okay, now I go to the map player, and this is actually kind of the same thing, right? We have ship, right? We actually see it. We actually see everything. Everything is left to hang, so to speak, right? Basically the same stuff, except for we can actually see our ships, because the player should be able to see their own ships, right? There's no reason to hide them. We set it up in the setup and it works. Now then, the whole end turn thing is the same exact arrangement. We have this event, right? Rather this event, and we have select square. Once it's clicked, the reference to that is provided, and it goes through, and then it gets invoked. And that's all there is to it. Now, if I go back, okay, just quickly, I go back and we have UI select. So this is quite important. After player finishes its turn, okay, after the player finishes its turn, right here, player finished, okay, from UI we change to AI, right? Well, actually, it's both should be AI. That's my little mistake from the past. But anyways, the point is really that we have a method which sort of deals with the turn of the AI, deals with the turn of the computer. The computer does its turn. It can't actually physically click it, right? We don't have some kind of a robot that clicks the button, so we have to do a little bit of an automation, right? So we have a randomizer right here. It provides a random digit, and then what we do, I'm going to zoom in a bit more, we have from squares players where, right, is not destroyed and is not empty. So at this point, we retrieve basically only the squares that can actually be clicked, right? We can't really prevent it in any other way, so we have to do it this way. We retrieve only those that can be clicked, and then we convert it to list just in case, right? And then we have index count, okay? We need the maximum index from that new list. We can't take the count from the old list because obviously that wouldn't work. It would go out of bounds and that would throw an exception. That's not good. And then finally, once we have those numbers and the new list, we can select a square, okay, by providing this particular random square. So it's going to be from the available squares now, element at, and we get the element at index used by the randomizer, generated rather by the randomizer. So that will be a number from 0 to however many elements are left in that whole list, okay? Because at some point it will only be 2 or 3. It won't be the whole list available to click. Now finally, you do need to have the state has changed thing because this deals with that reference. And again, if you want to learn more about these things, these sort of background tasks and things like that, you should definitely take a look at my course. So there's a bit of information about that, and there's a lot of information about many things. Basics of Blazor, accessing data from APIs, establishing WebSockets. So there's also lots of examples, and on the Confucian Solution Learning Platform you can actually submit the assignments for my review. So that's a kind of a nice feature to enhance your learning experience. Also take a look at my Stripe course as well. That's going to be quite useful. Now getting back to this, we looked at pretty much everything here. And again, I made a few suggestions on what you can take and improve. Hopefully it is interesting, it is enjoyable. You can find the code on Patreon, right? But again, we have quite a bit of code going on here, right? But what really saves the day is this, well, raises syntax, right? We don't have to write lots of IDs and lots of methods to basically generate these somewhere, right? It would be very difficult if you would try something like this on, say, WPF, right? It would be a lot more complex. Now, I love WPF, it's a great technology, but this simply takes a lot less space. It's just the way it is. As you can see, it's quite smooth. We just wrap it in different statements, ifs, else's, and loops and whatnot, and it's very, very readable. So Blazor is a good technology, and as you can see, it is possible to make a little game, and the code ends up being quite clear. Now, again, check out the code on my Patreon. Also, if you support me on Patreon, you'll get some great deals on my courses. You'll get them for free, actually. A few courses for free you'll get depending on the tier. And do check out my courses. And with that said, we will conclude this video.